Hello, algebra students. This is section 4 of chapter 2, where we're going to solve equations with variables on each side. The new twist to this section is there's going to be a variable on each side. So remember that the goal is to isolate the variable. So when there are variables on both sides of the equation, we need to get them all to one side. All right? And as we work this, I want you to remember, I've got the power. You've got the power to do whatever you want to any equation as long as you obey the golden rule and you do the same thing to both sides. So looking at example 1, it says solve and then check. And why wouldn't we check? To make sure we get it correct. So I have 10p and I have 8p. I can do anything I want to, so I'm going to subtract 8p because I'd like for my p to be positive. So if I subtract 8p from both sides, I've canceled 8p. I have left negative 1 on the right. I have negative 2 still out here, and then a positive 10 minus 8. Opposite signs. Remember how to subtract integers with opposite signs. You subtract and keep the sign with the largest absolute value, so that'll be a 2p, and I wanted it to turn out to be positive. Now all I need to do is add 2 to isolate 2p, and 1 plus a negative 1 plus 2 is going to leave me with a positive 1. Now I'm ready to divide to undo what's happening to p, and p is 1/2, or at least I think it is. Let's check. Negative 2 plus 10 times 1/2, my ink doesn't want to work, times 8 times 1/2 minus 1. So this is going to give me negative 2 plus 5. Does that equal 4 minus 1? 3 equals 3. It does check out. Okay. I'm going to let you attempt example B on your own. Now let's move on down to example 2. It says solve and then check. And beware of parentheses or parenthesis. Parentheses are your friend, but if there are a variable and a constant within parentheses, you can't combine them. So in this problem, 4 here needs to be distributed to everything inside the parentheses. 1/7 needs to be distributed to everything inside parentheses, because these are not like terms, we cannot combine them. So everything in the parentheses has the 4 being multiplied by it. So we end up with 8r minus 32 equals 1/7 of 49 would be 7r, and 1/7 of 70 is 10. Now I'm ready to get my r's together. Again, I want my r to be positive, so I'm going to subtract 7r because I have that power to do whatever I want. Now I have r, but I have minus 32 still and a 10 left over here, so I'll need to add 32 to both sides, and r, because those cancel, equals 42. Now let's check. 4 times 2 times 42 minus 8. Does that equal 1/7 of 49 times 42 plus 70? And we've not been using our calculators, so that's okay. We'll stretch our brain a little bit. We'll get 84 minus 8, and this is going to be the one that's hardest to do. 49 times 42. Let's go over here and do that math. So we have 8, 15, 2058 plus 70. And I made a little typo right here. That was supposed to be 1/7, not 1/2, so 1/7. So here I go. 84 minus 8 leaves me with 76. 1/7 of 2058 plus 70 is 2128. Now I'm ready to multiply times 4, which gives me 304, and 7 goes into 21, 3, and it won't go into 2, and it goes into 28 4 times. So, does it check out? It sure does. So again, I've taken up too much room. I would like to see you work B. If you need another sheet of paper to do example 1B and example 2B on another sheet of paper, feel free to do so. All right, there may not always be a solution to an equation. What? That's right. Let's see what happens to this one. First thing I'm going to do is get rid of my parentheses, distribute my 5 times m minus 35, and then there's minus 3m still out there. Let's combine like terms on one side of our equation. So 5m minus 3m leaves us with 2m minus 35. And if I look right here, 2m plus 5 can never equal 2m minus 35. But if you didn't see that and you tried to combine like terms, what happens here is you end up with 5 equals negative 35, and that's not true. And if you still didn't see it and you subtract 5 from both sides, or you add 35 to both sides, you'll eventually end up with 0 equals negative 40, and that for sure is not true. So this wasn't true, this right here wasn't true, nor was this true. And if you saw it as early as here, you can go ahead and say no solution to this problem. Or sometimes we'll use the null set for no solution. All right, I'm going to let you try B on your own. Now let's go down here and see what happens when sometimes equations are an identity and all numbers make it true. That's all real numbers, by the way. That's that fancy R. All real numbers make it true. Let's see what happens. We distribute our 3r plus 3 minus 5 equals 3r minus 2. Combine like terms, so we have 3r, and you can say plus negative 2 if you'd like, or just minus 2. It's whichever one you're comfortable with. This has minus 2. That's the same thing as plus negative 2. Oh, so we have exactly the same thing. So no matter what I plug in for r, whether it's 10 or 1,000 or 1,000,000, if I plug it in for r, I'm going to have the exact same thing on both sides. So it's going to be capital R, that fancy double bar R stands for all real numbers. All real numbers, but you can just do the R for me on your homework and on your test. So I'm going to let you do B. I'll give you a hint. It should turn out to be all real numbers. And example 3 should turn out to be no solution. But the other two you're going to have to find out for yourselves. All right, that's all I have for today. I hope you have a great day.